Hello. So now we are getting into, I know I keep saying this, but legitimately we are getting into more of an exciting portion of chemistry because we are doing chemical equations, which leads into chemical reactions. So that's always fun because then you actually get to see things happen. And as a lot of you like to say, make things go boom, which is not really the case here, but really we're learning a lot of the background when it comes to balancing these equations. And so previously we learned about chemical formulas and what that means to read them. So now we're going to take those we're going to take those chemical formulas and we're going to put them into a situation where they turn into something else. And so we previously saw this when we made magnesium oxide, but we don't really know all of what's behind it. So we knew that the mole to mole ratio was 1:1, but there's really not much else that you know about this. So in this video, you are probably going to get a lot of review from Science 1. It's the introduction video. So generally when we do the introduction videos for everything we've done so far this year, it's pretty basic stuff that you feel like you already know, but I still got to go through it to make sure that everybody's on the same page. So at the end of this video, you should be able to describe chemical reactions using using word equations. You should know the correct symbols to use in order to write skeleton equations for chemical reactions. And you should be able to use coefficients to balance chemical equations so that the law of conservation of mass is followed. And so, I mean, like, you probably know how to do all of these things, but I'm just putting some nice, big, fancy words behind it. When I walk through it, you'll see what I'm talking about. So think back to the lab last week. Some of you did not have the greatest turnout in the lab, and that's okay. That happens in science. But think back to your neighbor or to another person in the class and look at what they saw in order to know they saw a chemical reaction. They saw like smoke happening. They saw color change, really bright lights flashing. These are things that indicate a chemical reaction. And chemical reactions happen every single day in your life, believe it or not. Like photosynthesis, that's a chemical reaction. Cellular respiration, how we breathe, how we bring in oxygen into our body. Use that oxygen to transport throughout all of our body and our muscles. It's a huge chemical reaction. Batteries, and you use a battery every day. These are all different types of chemical reactions. And so now we're going to talk about what it takes to make a chemical reaction and what's on one side, what's on the other. How do we go from A to B? So the very first thing, you always begin with reactants, which are converted to new substances known as products. That's the very basics of a chemical equation. Your reactants will never look the same as your products. So that's why when you typically see a chemical equation, you see it and it looks something like this. So I'm just going to put R for reactants, yields your products. So if you're thinking about like equations, you typically are thinking of X equals Y and whatever equation you're dealing with. In chemical reactions, that's not the case because your reactants don't look like your products anymore. They're completely different substances. So a chemical reaction, big thing that you do in a chemical reaction is that you can introduce fire or heat into this component, and that creates a brand new substance. For example, hydrogen by itself will not make water. Hydrogen and oxygen in the right amount with some heat will make water, and hydrogen and oxygen by themselves will not be water just sitting there. There has to be something that actually happens. So what chemists typically say is they say reactants will yield products. And we know that those products are not going to look 100% like the reactants. So chemical reactions can be viewed or written or even talked about in a number of ways. And one way we talk about them is through word equations. So for example, if I were to say I have a silver spoon and it's been exposed to sulfur for so long, I have created silver sulfide, which if you know anything about silver, it's when like that it tarnishes that silver, so it makes it look like a darker, streaky black look. And that's just what's going on. The exposure of sulfur to silver will cause silver sulfide, that nice tarnished, ugly look. And we can just do this simply by putting silver plus sulfur will yield silver sulfide. Or we could write the words hydrogen plus oxygen will yield water. These are just word equations to represent the chemical reaction. But a better way to do this is by using a chemical equation. And so a chemical equation is the representation of a chemical reaction that displays the reactants and the products with chemical formulas. This is the way we will always do it in class. We will start off by talking about these things in words, and then we will eventually just do everything with the chemical formulas that we've already talked about in the previous chapter. So the chemical equation for the reaction, so for example, if I have methane and oxygen, that will yield carbon dioxide and water. And how I would represent that is just by the chemical formula. So instead of writing methane, I would write CH4. Instead of writing oxygen gas, I would write O2. Then I would have my yield sign, which is just my arrow sign, yield CO2 or carbon dioxide plus water, which is H2O. And that's what's known as a skeleton equation. And I know I'm not writing this on the screen as you're listening and you're like, where is she getting all this stuff from? I am going to write this in your notes. I do have quite a bit to add after each slide, so please make sure that you are leaving a good amount of space, because I do have like some symbols I'll be adding and all of these and various examples of all of this. So make sure you have room. So I forgot to even describe skeleton equations. My bad. Skeleton equations are equations that show only the formulas of the reactants and products with nothing to indicate the relative amounts. So we don't know, besides the fact that we have like the subscripts, we don't really know if it's balanced. We don't know if it's a gas or a liquid or a solid at that room temperature or whatever temperature we're looking at. So we have to add just a little bit more to our skeletal equation. But the very first step in writing any chemical reaction, you always need to make sure that you have the correct chemical formulas for all of the product or reactants and products that you're talking about. Another thing to make sure you do is that all reactants are written to the left of the yield arrow, separated, and then the products are on the right of the yield arrow. Now, the really, really, really fun stuff, balancing chemical equations. And why wouldn't this be fun? You've probably done some basic balancing of equations. So I'm not really worried that you don't know how to do this. But when we start doing our balanced equations, they're going to be a little bit more advanced. It'll make you think a little bit. There are a few rules you'll want to follow, or basic guidelines. However you want to do it, that's on you. But there are guidelines to it. One thing I wanted to make sure you understood, and I put it on as the top bullet point here, is that subscripts after each symbol in the product stand for the number of that particular reactant found on the reactant side. So basically what I'm saying there is that whatever products you have at the end will equal the reactants that you started with. You cannot create or destroy atoms. You cannot create or destroy atoms in a chemical reaction. Everything is conserved. The reason why in a chemical reaction it'll look like you've lost some of your compound is because maybe you have it in an open environment or an open area, meaning some of your reactant will absorb into the environment. And that's a very strong possibility. We've done this in the lab with the law of conservation of mass, where you saw in a closed environment we had the same amount. You will never gain or lose any products or reactants. So what is a balanced equation? A balanced equation is a chemical equation in which mass is conserved and there are equal numbers of atoms of each element on both sides of the equation. So basically, like I just said before, reactants equal products. That means if I have 2 carbon on the reactant side, I have to have 2 carbon on the product side. So this goes all back to the same idea. You need to write your skeleton equation. Make sure you have the correct chemical formulas for everything. And the reason why balanced chemical equations have to happen is because of the law of conservation of mass. And I've already explained this I'm just kind of jibber-jabbering, but the law of conservation of mass is the idea that mass cannot be created or destroyed. We can't create or destroy atoms. John Dalton told us that a long time ago, that these atoms are the most finite thing and you cannot create or destroy them. So in every chemical reaction, we always have that conservation of that mass. So balanced chemical equations will represent that law is always followed. Another good word that you should know, and I don't have it written down here, so I'll add it to the notes. A coefficient is a small whole number placed in front of a formula in an equation in order to balance it. So the subscripts in your formula go with your atoms. So for example, remember there are 7 elements that live in nature, and they're found as a gas or a diatomic element. So hydrogen is one of those, fluorine, chlorine, nitrogen. These are things that are found in twos or diatomic. So whatever subscripts you have, those do not count as your coefficients. Your coefficients are what's used to help balance that equation. So like I said, let's say I have carbon and I have hydrogen and I want to make methane or CH4. Now, if I just have one carbon and H2, remember that's a diatomic element, that's not balanced. That means I have one carbon on the reactant side and one carbon on the product side. Carbons look good, but I only have 2 hydrogens on the reactant side and 4 hydrogens on the product side. So I need to balance that. And so that's why I would add a coefficient in front of my hydrogen in my reactant side to give me CH4 or give me H4, which is balanced on both sides. So I know, like, again, I'm saying a whole bunch of words and you're just probably letting it run and run. The time is running as I'm making this, thinking I'm helping you so much. But I'm really just trying to get you that point across. I know that a lot of this is a review. We are going to talk about this in class, and there are a series of 6 steps that will help you to always find the balanced chemical equation. Now, whether or not you want to write those down, that's completely up to you. When we look at them, if you're like, yes, I should probably have these just as a backup, great. I'm not going to write them here. I'm not even going to talk about them right now because most of them are just a review. But once you are done with this video, we are going to balance equations in class. We are going to make sure that everything is equal on both sides. That's pretty well the end of my video. If you have any questions, please make sure you ask me on Edpuzzle. It's not a very long video. We will spend quite a bit of time balancing equations. They will become more advanced as we progress into this lesson.